In this video lecture, we're going to be discussing compound formulae. Now, there may come a point where you are required to solve a question of the following form. Sine of 20 degrees being added to, let's say, another angle of 40 degrees. Now, you may expect that it may be as easy as saying that sine of 20 plus 40 is simply sine of 20 being added to sine of 40 degrees. However, this is not the case. So, sine applied to the sum of two angles is not equal to the sum of sine applied to those individual angles. So, whenever you have a trig function being applied to the sum or perhaps the difference of two angles, we then call that a compound formula. And in those cases, we then have special formulae for each of them. So you could be asked to calculate sine of alpha plus beta or alpha minus beta, where alpha and beta are two angles, or cos of alpha plus beta or alpha minus beta. So either the sum or the difference. And in the case of sine of alpha plus beta, we then have that the compound formulae to calculate it is actually equal to sine of alpha times cos of beta being added to cos of alpha times sine of beta. So observe that when you have sine applied to the sum of two angles, the sign is then preserved. So we still have addition being involved. In the product, we then have sine followed by cos, and after you add, you then have to swap around, in which case you have cos followed by sine. Observe we had sine being applied to alpha, so we then had to swap it around to ensure that cos was also being applied to alpha, and vice versa when it comes to beta. So in the case when you are now applying sine to the difference between two angles, the formula has the same format as above, except that we no longer have an addition sign, we now preserve the minus sign, so we will have a negative in there. And now I'm just going to copy the rest of the formulae as we see it. Now, in the case when we are calculating cos being applied to the sum or difference of two angles, it then has the following format. We have cos followed by sine, and then just follow the order in which the angles appeared. So it's alpha, alpha, and beta. Now, the change in here is that when we are computing the compound the compound formulae for cos, we then change the sign. So this then becomes minus. And of course, when we're now dealing with the difference, it then becomes plus. And of course, I'm going to preserve the way it was written before. Cos of alpha times cos of beta being added to sine of alpha times sine of beta. Now, you may be saying that these are a lot to learn in terms of memorizing the formula, and in which case you don't have to. This is provided in your formula sheet. However, I would advise that you go through it, learn it, and understand how to apply it. Right, so this is in your formula sheet. Right, another type of formula that you may encounter is those involving double angles, meaning whenever you have an angle and we're taking twice of it. So in that case, we will require the formula for sine of a double angle and cos of a double angle. The formula for sine of 2 alpha, where alpha is some angle, is just equal to 2 sine alpha times cos of alpha. So it's twice sine followed by cos, right? So find a good way to actually remember what it is. Then cos of a double angle, there are multiple forms of this formula. Again, all of the formulae is in your formula sheet, right? The first form is it can be cos squared of alpha minus sine squared of alpha. Observe that this is different from what you had counted before. Before we had added sine squared to cos squared to equal to 1. So when we're taking the difference, when we say cos squared minus sine squared, it now equals to a double angle. The second form is that you may find it written as 2 cos squared alpha minus 1. And the third form is that you may then find it written as 1 minus 2 sine squared alpha. Right, so these are the formulae that you need to know. Once again, everything is provided in the formula sheet. but ensure that you understand the format and how to apply it. So to ensure that we understand these formulae, let's look at some examples. Right, so here's the first. We now need to simplify without the use of the calculator. I've got 3 questions there for us to cover, right? So let's focus on the first one. Right, so observe that this does look that it resembles a compound angle formulae, because we have the product of 2 cost functions being added to the product of 2 cost ratios or functions again. But if you look at the list that we have, it doesn't equal to any of them. But it does look similar to the compound angle formulae involving costs, because it's cost times costs being added or subtracted to sine times sine of the angles respectively. But here we have costs being added to costs and costs again. So what we would like to do is, can we change this to sine of something times sine of something else? Is it possible? And if we investigate closely, you will observe that it is, because remember that sine and cos are co-functions. Remember your formulae that, for example, sine of 90 minus alpha or x is equal to cos of x. And similarly, cos of 90 minus x is equal to sine of x. So we have these properties in place. So keeping that in mind, leaving the first term as is, cos of 70 times cos of 10 degrees, and now changing this according to our co-functions, this then equals to sine of 70, because 70 plus 20 gives us 90, times sine of 10, because again 10 plus 80 gives us a total of 90 degrees. And now observe that this is indeed the form of the compound angle for cos when it is being applied to the difference of 2 angles. So we've got the form cos alpha cos beta being added to sine alpha times sine beta. That's precisely what we have here. So this is our alpha and this is our beta. Let's keep that in mind. So rewriting this now equals to, based on what we have observed, cos of alpha minus beta, which is 70 minus 10 degrees, which means this is cos of 60. Again, we are not using a calculator, so it is wise for us to make use of the diagrams that I had gone through in the previous videos. Right, so which right angle triangle involves the 60 degrees? So recall this triangle. If that's 60, this must be 30, since that's 90. And that has length 2, 1, and root 3. So keeping this in mind, we want cos of 60. Cos is adjacent over hypotenuse, so cos of 60 equals to half, and that's how we calculate that question. Looking at the second question, it's 2 times sine of 15 times cos of 15. Going back to our previous slide, 2 times sine of an angle multiplied to cos of an angle is just the double angle formulae for sine. So this is equal to, remember our angles are the same, so this is just equal to sine of 2 times 15, which is just sine of 30. And once again, this is a special angle, so using that triangle we could compute this. Right, so sine of 30, sine is opposite over hypotenuse from our SOHCAHTOA slogan. So this is 30, opposite is 1 over hypotenuse, which is 2. So that's our final answer in there. And finally, the last question says, compute sine of 15 degrees, again without the use of the calculator. So in order to ensure that we don't use a calculator, we would like to use the triangles that we had learnt before. Observe that 15 can be expressed as 45 minus 30. So this is actually sine of 45 degrees minus 30 degrees. And we have a formula for this because we know that this is a compound formulae. So the sine of the difference of 2 angles, using that formula, if this is alpha and this is our beta, then this then becomes sine of 45 times cos of 30, and remember with sine we preserve the sign that was used, so it's a negative as we have above, and continuing, this then becomes cos of 45 multiplied to sine of 30. So we now have angles 45 and 30, so we will require our special triangles. I've already got the triangle involving 30 degrees. I now need the triangle that involves 45. Right, so this is the right angle, so that's 45 and that is 45. Length 1, and length root 2. So we can now compute the trig ratios involving 45 degrees. Sine of 45 degrees, again remember, so katoa, opposite over hypotenuse. So if this is the reference angle that I'm using, opposite is 1 over hypotenuse of root 2. So this is 1 over root 2. Being multiplied to cos of 30, so there's my reference angle. Cos is adjacent over hypotenuse, root 3 over 2. Minus cos of 45, again adjacent over hypotenuse, which is 1 over root 2, multiplied to sine of 30, opposite over hypotenuse. So that's my reference of 30, opposite is 1, hypotenuse is 2. And so we can then multiply these together. I then get root 3 over 2 root 2 minus 1 over 2 root 2. I've got like common denominators in there, so this is 2 root 2, and in the numerator it's root 3 minus 1. You may leave your solution as it is. So that is how we solve these questions using both compound formulae, as we had done there, as well as co-functions, as well as applications of double angles, and once again an application of compound formulae, as well as special angles using our triangles. So this was definitely a mashup of all of the things that we've learned so far.